More of the amazing adventures of Math Bike. Let's look at this from a different perspective. So we've got several different circles arranged around the bike, and they do not all share the same center point. So the rear tire and the rear gear both have the same center. It's this axle right here, and they both rotate around the axle together. So every time the tire makes one rotation, the gear also makes one rotation. They'll have the same rotational speed. They'll have the same angular speed also. But since the radii are different sizes, they're going to travel a different distance. The little radius travels a small distance when it makes one rotation. The big radius travels a large distance when it makes one rotation. But the linear speeds will be different. Same center point, different radius, different linear speed. The gears, the front gear and the rear gear, also have different radius, but more importantly, they have different center points. So since they have different center points and a different sized radius, they will not have the same rotational speed nor the same angular speed. However, linear speed will be the same. So I'm going to make an analogy. We can think of linear speed like running speed. You can imagine these little teeth on the gear are like tiny little legs running on the ground of the chain. So since both gears are running on the same ground, they will have the same linear speed. Tiny little legs. Okay, another comparison we could make is the tires, the front tire and the rear tire. They're not attached in any way, and they're both on the same bike, but they don't touch each other and they're not connected by a chain. However, they both roll on the same ground. No analogy necessary. They both touch the same ground. So if the bike is moving, I'm out actually riding it outside, you can imagine the tiny little grippy parts of the tire, like tiny little legs running on the ground. Since both tires are touching the same ground, they'll have the same linear speed because of that. Different center points, but they're on the same ground. Of course, both tires have exactly the same radius. So since they have the same linear speed and the same radius, even though they have separate center points, they will also have the same angular speed, the same rotational speed, in addition to the same linear speed. Here's a different wheel. It looks like it's the same size as that rear wheel on the math bike, but it's not. If I was going to give it the same linear speed, I would have to roll it on the ground. Would I have to roll it so that it spun faster or slower?